Hello everyone. Today we are going to present our project, which is based on the research article, and we have read couple of research articles and whatever the knowledge which we have gained as we are going to produce the what we have done today. And our research article is based on the end-to-end framework for efficient and secure IoT systems with operating system support. So whatever we are of team of group 11. So we are of the team members, me, Harikrishna Kaka, Likit Taminidi, and Sudhir Vadlamudi. And the first slide is going to start it by the Likit Taminidi, and I'm going to hand over the presentation to the Likit.
In this abstract, the realm of crafted and sophisticated and impenetrable IoT system, backing the operating system support, this captivity research article unveils a conceptual literature review and put forth on all-encompassing framework seamlessly for device management and edge computing and resource management, communication, research, and privacy. Here in the crucial, in this crucial of existing research articles uh, and industry reports, there are like five key IoT topics, reveals common themes, challenges, gaps, and the framework seeks to enhance the security, performance, and efficiency of IoT systems. And and uh, and the framework combines the device management, edge computing, and resource management, communication, security, and privacy issues. The articles delves into captivating discourse, examining the potential benefits and the limitations of the ingenious framework. Coming to the introduction, uh, the IoT plays an important role representation in the terms of digital transformation, transforming industries like healthcare, transportation, and manufacturing, which enable us to uh, easily, seamlessly, and optimal resource allocation and efficient management and security to safeguard the whole IoT ecosystem from the insidious forces. There must be emergence of the security measures need to be erected. Coming to the next slide. The IoT system is interlinked with the operating system, which act as the interface between the hardware and software component. An important role is played by the operating system in the resource management, data handling, and looking at the seamless interaction between the devices and also application. The free RTOs and GIF, GIFIR are the commonly used uh, for the IoT devices with limited processing power and the memory and embedded OS. Coming to the next slide. In this research, we have focused on five key topics. First one is like IoT management and operating system, and second is edge computing and operating system. And coming to the third point is like IoT resource management and operating system, and fourth one is communication in IoT and operating system, and the final one is IoT security and privacy and operating system. Uh, Next slide, literature review is gonna present by the Harikrishna.
Thank you, Ligit. Now I am going to present on the topic literature review based on the review of various research articles on the topic of IoT device management and operating system. Now we found that managing IoT devices is a crucial element within the realm of IoT systems and operating systems. It plays a vital role supporting the IoT device management functionalities and the key concepts and challenges in the IoT device management. The first one is device provisioning. The process of onboarding new devices to the IoT network and configuring them with the new necessary credentials and settings. And the next one is device configuration, managing the configuration of IoT devices to adapt to changes in the environment or requirements. Now, coming to the next slide, device monitoring, continuous monitoring of device health, performance, and status to identify anomalies or potential issues to maintain security and operational efficiency. Updating IoT device firmware regularly with latest patches is imperative. Now, the next one is device authentication and access control, implementing robust authentication mechanisms to prevent unauthorized access to devices and data. Now, coming to the next slide, existing approaches and their integration with operating systems. A variety of IoT device management frameworks with corresponding protocols have thus far been engineered to contend with difficulties intrinsic to administering such connected apparatus. For example, Open Mobile Alliance's lightweight M2M LM2M protocol provides a standardized approach for managing IoT devices over various networks. Now, coming to the next slide. One such example is the integration of LWM2M protocol with Contiki OS, an open source operating system designed for resource constrained IoT devices. Contiki's lightweight design and support for LWM2M make it an ideal choice for managing IoT devices with limited resources. Moreover, the merging of blockchain mechanisms with the device management frameworks has gained an attention for improving protection and trust in IoT environments. Now, coming to the next slide, edge computing and operating systems. Edge computing has emerged as a crucial paradigm in IoT systems, bringing computation and data processing closer to the source of data generation. Importance of edge computing in IoT systems. Edge computing reduces the data travel distance by processing data at near or at the source, leading to faster response times and reduced network congestion. Integration of edge computing with operating systems. The integration of edge computing with operating systems involves optimizing OS functionalities to support edge device capabilities. OS modifications may include lightweight virtualization, containerization, and real-time processing support to enable efficient edge computation. Now, coming to the next slide, IoT resource management and operating system, the oversight and distribution of finite resources, CPU, memory, network bandwidth, and power in IoT environments within networks of interconnected devices. Resource management challenges in IoT environments. IoT devices often have limited computational capabilities, memory, and power sources. Ensuring efficient resource utilization becomes a challenge when handling diverse workloads with varying resource requirements. Operating system support for efficient resource management. Operating systems tailored for IoT often incorporate resource management mechanisms to handle constrained resources effectively. Now, coming to the next slide, it will be handled by Sudhir Vadlamudi.
Thank you, Hari Krishna. Hi, this is Sudhir Vadlamudi. I am going to continue the slide presentation. And in this slide, we're going to discuss about the communications in the IoT and operating system. In this, the efficient and the reliable communication is crucial for the IoT systems to ensure the seamless data exchange between the devices and the cloud services. And the role of the operating system in facilitating reliable and secure communications are the most of the OS must support multiple communication protocols and also handles the complexities of different networking technologies. Ensuring the data security and encryption is the crucial to protect the sensitive information during the transmission. Okay, moving on to the next slide. In this slide, we're gonna discuss about the review of literature and recent advancement in this domain. The recent researchers such as these are the researchers we're gonna perform in this project. And furthermore, the emergence of 5G technology has introduced new possibilities of IoT communications. As operating systems adopt the capitalized on 5G slicing and the lightning fast network, they are poised to be turbocharged in the network of things, and also unlocks the new possibilities in self-driving cars and automated factories. Coming on to the next slide. In this slide, we're going to discuss about the IoT security and privacy of the operating system. The security and privacy are critical concerns in IoT systems, as IoT devices collect and also transmits the sensitive data, ensuring data confidentiality, integrity, and availability, while protecting the data against cyber attacks are essential to build the trust in the IoT deployments. The critical examinations of the research papers and industry reports are the key goal of these critical examination of research papers are to have the research has been to be implement hardware protections within the huge range of Internet of Things gadgets, with the overreaching aim of the family establishing a secure base of the trust. This honorable quest involves the use of various techniques such as trusted execution environments and hardware security modules. Coming on to the next slide. In this, we're going to discuss about the frameworks which are proposed in this project. The IOSE intends to seamlessly combine the edge computing and IoT resource management, IoT communications, and IoT security, privacy, robust uh, si- uh, privacy and robust operating system support. The 4.1 high-level architecture of IOC is masterfully crafted a high-level architecture in ingeniously engineered to facilitate an unparalleled level of modularity, scalability, and flexibility, thereby manifesting as the epitome of adaptability and customizability, seamlessly traversing the diverse and ever evolving landscape of the various IoT use cases. Coming on to the next slide. In this, these are the key components of the IOSC, which involves such as IoT device management module and edge computing module, IoT resource management module, communication in IoT module, and IoT security and privacy module. Moving on to the next slide. These are the interactions and benefits in this project, such as the strength of the IOC framework lies in the seamless interaction between the components, so enabling the holistic approach to the IoT management. The IoT management module ensures the proper onboarding and configuration of the devices, providing accurate device information to the resource management and resource management module. And this data-driven approach enhances the resource allocation decisions, optimizing performances and energy consumptions. And from the next slide onwards, my friend, by seamlessly integrating the key components like IoT devices management and edge computing management, IoT resource management, IoT communication, and IoT security and privacy, IOC empowers the deployment, the scalability, the dependability, and the protected IoT solutions. From the next slide onwards, my friend Kiran will continue the presentation.
Hello everyone. Now I'm going to present the remaining part. So next slide is about the rationale behind the proposed framework, design and approach. So IOSC takes a holistic approach by integrating these critical aspects with a strong operating system support, which is resulting in the cohesive and interconnected IoT ecosystems. The conceptual framework addresses identify the following challenges and improvements. So these are the five. When it comes to the first one, improved device management, and the next one is the real-time data processing, and the third one is the optimized resource usage, and fourth one coming to the reliable and secure communication, and the fifth one is enhanced security and privacy. These are the five things which are having in this conceptual framework addresses identified and the following challenges and improves. So next move on to the next slide. So here are the potential benefits and advantages of the proposed framework in the slide. So when it comes to the first one, the efficiency enhanced, the system complexity is reduced by the iOS's integrated approach, which will lead to the efficient IoT deployments and uh, streamlined device management processes. So, and the next one is the improvement in the security. When it comes to the iOS will improve the data privacy and also the security risk issues in IoT environment by leveraging hardware-based security and blockchain integration. As using of the iOS, which will improve the security in terms of and also protects from the cyber attacks. This will be explained in the second point. When it comes to the third point, the data analysis in the real time. The faster decision making can be enabled by the edge computing module by the edge processing of the data reduces the response time. So let's move on to the next slide. So when it comes to the limitations of the which we have been proposed framework, we are here is the in the slide we are going to present those. The complexity in the implementation, the integrating multiple components and ensuring the seamless interactions may require substantial initial development effort and enterprise. So for the as we are going with the multiple components and the seamless interaction, which we need the initial development and effort and expertise to do that. So this is all about the complexity in implementation which you are facing. And when coming to the next point, the hardware compatibility, the iOS's resource optimization may be limited by hardware constraints in the current IoT devices necessitating careful device selection. And let's move on to the next slide. So when it comes to the conclusion, when it that the iOS framework, which represents the significant step where it provides the efficient and security IoT system, building with the operating system support. So I was by using the iOS, which will provide the secure device IoT device, which will provide the protection against the external attacks, and there are many benefits with the integrated approach for the development of IoT system and also is security while going with the new opening up the future research and advancement in this field of IoT technologies. So thank you for giving this opportunity.